Good morning, students. I just wanted to talk briefly about the updates to the quick exam and specifically the dimensioning test which we'll be having during this week. So I've mentioned in the lectures that the circular problems, the circular dimensioning problems hadn't been completely bug tested in the script. Over the weekend I've made a few updates and so now we should be able to work through some of these examples. So just to show you a simple problem to start with, we'll go into the first circular problem and I'll run through this. So what you need to apply in a for a circular feature according to this script, you'll need to provide a radial dimension or a diametric dimension for every circular feature. I forgot to change the dim scale for my computer. For every radial feature, a circular feature, you should have a radial dimension. So this one is R 7.0. And if I were to give you a cylinder with a hole taken out of the center, told you how long it was, and told you that its internal diameter was, internal radius was 7 units, the only other piece of information you would need would be the outer diameter to describe the whole shape. So I'm deliberately leaving the outer diameter off for the time being to show you that we now have a feature, or the program can now identify a missed radial dimension and provide the dimension for you. So this works with even the more complicated problems. So if you applied a few dimensions to this object but failed to identify a large number of them, or say gave some of them which were redundant, like that one, we'll have that the program will identify the redundant dimensions that you've placed. It will also identify the remainder of your required dimensions. It takes a bit of time, a bit of processing power to work all that stuff out, but it can do this. So you see here that we've missed this radial dimension, that radial dimension, these ones as well. Okay, so in the test, if you happen to be working on an orthogonal problem, let's say we're on one like this one, get that message to go away. I'll run this full screen as well, not that it makes much difference. So on an orthogonal problem, it's reasonably straightforward. You need to provide a dimension for every feature of the shape, enough dimensions to show every length within the shape without any redundancy. So I'm going to provide this length and possibly this one as well, and let's get some height on the shape. Okay, so we have a total height, we have a height to this midsection, and we have a lower height. So I provided the height to the midsection, I provided the total height. That's everything I need in that direction. For the depth of the beam, I have the overall width, which is provided. I have the length to this section, which is identified by this dimension here. I have the length to this section here, which is provided by that dimension. And so everything in the y-axis, for lack of a better term, is also defined. Then for our x-axis, we have this feature's width here, we have this feature's width, and the overall width of the shape. So everything should be provided there. We see we have a completed diagram with no redundancy. Okay, so far so good. For your orthogonal problems, there isn't really a whole lot to do. Just provide the dimensions without redundancy. If you need to work on an angular problem, I've noticed a few students have been a bit confused by this. So if you'll notice that the description text in the top of the program says that the script works with dim linear, dim radius, and dim diameter. It does not work with dim aligned. And if you were to provide an aligned dimension for something like this, I mean, it may look okay enough. You've got 9.5 as the length there. But the properties of this object, if I change the amount of precision that we go to, you'll see that this is actually a very messy length here. So if you were to give some sort of work person a dimension like this and say, I need the length of this cut to be 9.486, this wouldn't really help them. Even if they wanted to try and work that out, they would need an angle and a length, and it would be quite tricky to do. What would be much easier is if that same person was provided with the rise of the shape and the run. So they've got the rise and the run of the triangle, and that lets them work out precisely the total length. It also gives them the angle, so all the information is contained by rise here and run here. And so in the angular problems, that's what I want to see. If you are dimensioning them with linear dimensions, make sure not to double that one up, or that one, putting linear dimensions on these things, then that's fine. That's all that you're required to do. So I'll just go ahead and finish off this shape. If you do miss anything, you can see that there's missed features will be provided for you. So it gives you a bit of feedback there. During the test, any missed dimensions will be -1 mark, and any redundant dimensions will also be -1 mark. Each problem is worth 2. So to get full marks, you really need to make sure you have no redundancy and no missed dimensions. We'll be going through 3 orthogonal problems, 1 angular problem, and 1 circular problem. I probably won't get you to do something like circular 6 or circular 7 because they are a little bit ambiguous. So like the dimensions around this centerpiece here don't exactly, they aren't tremendously intuitive. But anyway, that's the dimension test so far. So a few orthogonal problems, an angular, a circular. If you have any questions before the test, please come and see me, ask me during the exam. You should have everything that you need now to have nice pretty dimensions put on everything, so I trust that this has been a pretty simple topic to get through. I don't think I'll see too many people struggling through here unless they've put in next to no effort. Okay, thanks for watching.